problem comes when you have to give a number for N-butane, for example. N-butane has a chemical formula of C4H10. Okay, so you cannot give you cannot apply the earlier rule, because if you are applying the earlier rule, you find that a number of hydrogen atoms is 10. So the Y value will be 11. Okay, so Y value 11 means it has 2 digits. Okay, so that leads to confusion. So as a result, this N-butane has been given an arbitrary number, that is R600. Okay. Similarly, you have isobutane. Isobutane also is an isomer of butane, and its chemical composition is same as N-butane, that is it is C4H10, and it is given a number R600A. Okay. Again here the small letter A means that it is an isomer. Okay. You can also have unsaturated hydrocarbons, for example R1150. Okay. Here it is 4 digits, unlike the other refrigerants you have 4 digits here. 4 digits indicates that it is an unsaturated hydrocarbon. Okay. So the first digit 1 means that it is an unsaturated hydrocarbon, and the other letters you can again apply the rule and you can get the chemical composition. For example, second letter 1 means that number of carbon atoms are 2, third letter Y means that number of hydrogen atoms are 4. Okay. Fourth letter 0 means that number of fluorine atoms are 0. Okay. Similarly, R1270. Okay, this is C3H6, that is it is propylene. Okay. So that is how the numbering system is being used, and so this is the, you have to keep this in mind, so that you can, once you know the number, you can immediately, nobody whenever you talk about refrigerant, normally we designate it in terms of numbers only. Okay, because the chemical formula or the chemical names are very long. Okay, and always mentioning it in terms of the chemical names can be confusing. Okay. Next, let us look at the comparison between different refrigerants. Synthetic refrigerants. Okay. Synthetic refrigerants that were commonly used for refrigeration, cold storage and air conditioning applications are R11, it is a CFC11 chlorofluorocarbon, R12 that means CFC12, R22 HCFC that is hydrochlorofluorocarbon 22, R502 is a azeotropic mixture of CFC22, I am sorry. Okay, there is a mistake here. R502 is a mixture of HCFC22 and CFC115. Okay. Then these were used very widely, but these refrigerants had to be phased out due to their ozone depleting potential. That means all these refrigerants have non-zero ODP values. Okay. So due to this Montreal protocol, all these refrigerants were already phased out, or they have to be phased out. Okay. The synthetic replacements for the older refrigerants are R134A. This is a HFC, that means it is a hydrofluorocarbon, it does not contain chlorine. Okay. So its ODP value is 0, so it can be used, right. So this is one of the synthetic replacements for the older refrigerants. In addition to that, the various blends of hydrofluorocarbons are also being used as synthetic replacements. Generally, synthetic refrigerants are non-toxic, non-flammable and are compatible with various materials of construction. So these are the main advantages of synthetic refrigerants. However, compared to the natural refrigerants, these synthetic refrigerants offer lower performance and they also have higher global warming potential. Okay. Normally you find that their COP values are much lower than the natural refrigerants. Okay. That means the efficiencies are lower. Okay. Also the thermophysical properties are also not as good as that of natural refrigerants. Okay. And in addition to this, they also possess high global warming potential. Okay. As a result, so all the synthetic refrigerants face an uncertain future. Okay. Even though right now there is no ban on them, we really do not know. Okay. In future they may be banned or they may be phased out. Okay. The oldest and most commonly used natural refrigerant is ammonia. Okay. It is more than 100-year-old and it is still being used very widely. Ammonia has excellent thermodynamic and thermophysical and environmental properties. It is inexpensive, it is easily available. However, it is toxic and it is not compatible with some of the common materials of construction such as copper or brass. Okay. So these are the disadvantages of ammonia. Okay. Toxicity, incompatibility with common materials. It can also be flammable under certain conditions. Other natural refrigerants that are being suggested are hydrocarbons and carbon dioxide. Okay. Hydrocarbons and carbon dioxide were used in the olden days. Okay. If you remember our lecture on history of refrigerants, these were very widely used in the early days of refrigeration, okay, but later they were phased out because of some perceived problems such as flammability and low critical temperature, etc. Okay, but they have made a strong comeback because of their excellent thermodynamic and thermophysical properties, and mainly because of their environmental friendliness. Okay. So, as I said, in spite of some practical problems, these refrigerants are being considered as they are environmentally safe, inexpensive, and offer good performance. Now, let me show some commonly used refrigerants and their salient features and properties. Okay. So, first refrigerant is R11. R11 is a chlorofluorocarbon. Okay. So, it is a CFC. Right. It has a normal boiling point of 23.7 degrees centigrade. Since its normal boiling point is quite high, that means it is 23.7 degrees centigrade, its operating pressures will be low. That means, if you want to use it for air conditioning applications, say at 7 degrees evaporator temperature, that means the evaporator will be operating at under vacuum condition. That means the pressure will be subatmospheric. Okay. So, this is a disadvantage of R11. Okay. And the specific volume of the refrigerant will be very high because the pressures are low. Okay. So, these are two disadvantages of this particular refrigerant. However, since it has other advantages, this is still used, and it is mainly used along with centrifugal compressors. Okay. It is used with centrifugal compressors because of its high specific volume. Okay. And its latent heat of vaporization at normal boiling point is 182.5 kilojoule per kg. Its critical temperature is almost 198 degrees centigrade, which is good, and its isentropic index of compression is 1.13. Okay. And its ODP is 1 and its GWP is 3500. Okay. Since its ODP is 1, this is banned. Okay. It is a ozone depleting substance, right. So, it is no longer used. And what were its applications? Its major applications were in large air conditioning systems, in industrial heat pumps because of its high critical temperature, and it was also used very widely as foam blowing agent in polyurethane foams, etc. Since it is phased out, substitutes suggested in its place are R123, and R123 can be used in older R11 systems or in new systems also. Okay. That means, it can be retrofitted and it can also be used in new systems. Then R141B, R245FA and N-pentane. Okay. Mainly R145B and N-pentane are used as foam blowing agents in place of R11. Okay. Next, you have R12, another very popular refrigerant. This is also a chlorofluorocarbon. It has a low normal boiling point of minus 29.8 degrees centigrade. That means, its evaporator pressures will be higher than atmospheric if its evaporating temperatures are above almost minus 30 degrees centigrade. Its latent heat of vaporization is 165.8, critical temperature is also high, 112.04 degrees centigrade. Cp by Cv value is 1.126. Major problem is it is also having high ODP, that means ODP is 1, and GWP is also very high. So, this is also banned. Okay. And before the ban, it was widely used in domestic refrigerators, small air conditioners, water coolers, and small cold storages. Since it has to be phased out, replacements have to be found for it. The most popular replacement for this is R134A in domestic refrigerators and small water coolers, air conditioners, etc., and blends of hydrocarbons. Okay. In addition to this, the other refrigerants replacements are also shown here, like R22, 227EA, etc. Okay. Next is R22. This is a hydrochlorofluorocarbon. This is another very widely used refrigerant, and it has a normal boiling point of minus 40.8 degrees centigrade, and it also has a reasonably high latent heat of vaporization of 233.2 kilojoule per kg, but it has a lower critical temperature of 96 degrees centigrade compared to R12, and its Cp by Cv value is also relatively higher. So, that means, its discharge temperatures will be high, and its ODP value is non-zero, but it is quite low. Okay. So, it has a ODP value of 0.05. So, it is also a substance which has to be phased out, but unlike R12 and R11, some time is allowed for this for phasing out. Okay. So, you can use it till almost 2030. Okay. So, you can still use it. It also has a global warming potential, and it is mainly used in air conditioning systems and cold storages. Okay. and since it also has got to be phased out, some substitute has to be found. Okay. Again, these are the major substitute. You can see that according to our numbering system, all these 410, 410A, 410B, 417 etc. are geotropic refrigerant mixers. Okay. Whereas 507, 507A are azeotropic refrigerants. Okay. And you can also replace R22 by ammonia, that is R717, but not as a retrofit, but as a new system. Okay. Another important refrigerant is R134A. This is a hydrofluorocarbon. Its properties are almost closest to R12. Okay. It has a normal boiling point of minus 26.15 degrees centigrade. Its latent heat of vaporization is good. Critical temperature etc. are also shown here, and it is used mainly as a replacement for R12 in domestic refrigerators, water coolers, automobile air conditioning systems etc. Okay. No replacement is required as yet because its ODP value is 0. Okay. There are some problems with this. The problems are it is immiscible with mineral oils, so you cannot use mineral oils as lubricants, so you have to go for synthetic lubricating oils, and it is also highly hygroscopic. Next comes refrigerant ammonia R717, and its normal boiling point is almost minus 33 degrees centigrade. It has a very high latent heat of vaporization at normal boiling point because of its low molecular weight. Okay. Its critical temperature also quite high. Its Cp by Cv value is high, which is a disadvantage. So, you have to use water cooled compressors to keep the compressor temperature low. Okay. It is excellent as far as its environment friendliness is concerned because its ODP is 0, GWP is also 0. So, its major applications are in cold storages, ice plants, in food processing, and in frozen food cabinets etc. Okay. You do not require any replacements for this. Some problems are it is toxic and flammable, and it is incompatible with copper and brass. Advantages are it is highly efficient and it is inexpensive and widely available. Next comes R744, this is carbon dioxide. It has a very low normal boiling point of minus 78.4 degrees centigrade, but still its freezing point is about minus 56 degrees centigrade. So, you cannot use it for temperatures below minus 56 degrees centigrade because of its freezing point. Okay. And it also has good latent heat of vaporization. Major problem with this is its critical temperature is very low. Okay. That is the reason why it was phased out, but alternate cycles have been devised, that is transcritical cycle, where the condensation process is replaced by a gas cooling process, and this is made a strong comeback because of this reason, that means because of the modification in the cycle. Okay. Other important properties are it has a low ODP, and it also has it has non-zero ODP. Okay, I am sorry, and it has very low GWP. Okay. And its major applications are in cold storages, in air conditioning systems, in simultaneous cooling and heating if you are using a transcritical cycle. You do not require any replacement, and major disadvantage is low critical temperature and high operating pressures. Okay. I did not mention this, but its operating pressures are very high, and it is eco friendly, and it is inexpensive and easily available. Next is water, that is R718. Major problem with water is its high normal boiling point of 100 degrees centigrade. Okay. That means your operating pressures will be under high vacuum. Okay. Since it has a low molecular weight, its latent heat of vaporization is very high. It is an excellent from this angle. Its critical temperature is also very high. It is very good. The problem of course is Cp by Cv value is high. It is perfectly environmental friendly because its ODP is 0 and GWP is very low, and its major applications are as refrigerant in absorption systems and as refrigerants in steam jet systems. Okay. And its features are you do not require any replacement because of its excellent environmental properties. Disadvantage is high normal boiling point, okay, and high freezing point, so you cannot use it for sub-zero temperatures. Large specific volume, so you cannot use reciprocating compressors or anything because of this. Large specific volume is because you are operating the system at very low pressures. So, its main advantages are eco friendliness, inexpensive and availability. Next is R600A, this is isobutane, this is a hydrocarbon. Okay. So, its normal boiling point is minus 11.73 degrees centigrade, its latent heat of vaporization is reasonably high, its critical temperature is very high, Cp by Cv value is low, it is good. Its ODP is 0, so it is perfectly safe as far as ozone layer depletion is concerned. GWP is also very low. Okay. So, this is used as a replacement for R12 in new systems. You have to change the compressor in domestic refrigerators, water coolers, etc. Okay. Its features are you do not require any replacements. Its main problem or main concern is it is highly flammable, and its main advantage is it is eco-friendly. Okay. So, this table is not actually comprehensive, because there are many other refrigerants with many other features and many other problems also. Okay. Now, let us briefly look at refrigerant mixers. Refrigerant mixers are mixers of 2 or more pure refrigerant fluids. The refrigerant mixers can be divided into, as I said, azeotropic mixers, geotropic mixers. The azeotropic mixers are usually binary mixers that behave like a pure fluid. Okay. So, for all practical purposes they behave like a pure fluid. Okay. The example is R502, which is a mixture of R22 and R115. This was mainly used in cold storages, etc., but this is banned because of R115, which is a ozone depleting substance. Then you also have R410A. Okay. This is R32 plus R125. Even though this I am calling it as an azeotropic mixer, its number is 4. This is what is known as a near azeotropic mixer. Okay. That means its temperature variation during phase change is very small. Okay. It is a replacement for R22. Geotropic mixers exhibit a significant temperature variation during constant pressure phase change process. That means when evaporation or condensation is taking place at a constant pressure, temperature does not remain constant. Okay. For pure fluids, temperature remains constant, but that means the process is isothermal, whereas for geotropic mixers, temperature of the refrigerant varies during phase change. Okay. So, this is a major difference. Also, at equilibrium, the composition in vapor and liquid phases will be different. Okay. So, these are the differences between geotropic and azeotropic mixers. Examples of some geotropic mixers are R404A, which is a mixture of R125, R143A and R134A. Okay. This is mainly used in place of R22. Then you also have R40. This is a mixture of 32, 125 and 134A. Okay. This is also used in place of R22. Then you also have R407C, which is used in place of R22. Okay. Then mixers offer the advantages of tailoring the composition to suit various temperature requirements. This is a major advantage of mixers. It is also possible to control the properties such as toxicity, flammability, oil miscibility by manipulating the composition. Hence, they are finding greater use. Okay. However, since the composition of geotropic mixers change due to leakage, this is a major problem. Use of these substances require greater care. Okay. And design of equipment such as evaporators and condensers is also complex because of the temperature variation during evaporation, condensation, etc. In the next lecture, I shall take up air conditioning. Okay. Thank you.